Okay, this topic, differentiation or pembezaan, this topic in English we call differentiation. In bahasa Melayu is pembezaan. Okay, before I start, I just want to share about your mid test. I have announced the marks, the result for your mid test. Okay, the grade the mark is for 100%. Okay, I received a few questions from a student related to this test. Okay, what the question is about the passing mark, and also I think most of a question is about the passing mark. Okay, okay. For mid test, uh, uh, the passing mark for mid test is 50%. 50%. So in other words, you must get at least 50% in order to get the passing mark. For the overall, for the whole grade, for the final grade that after your final exam, your test, mid test, your quiz plus your mark for your test, your quiz, and also your final exam. Okay, for total mark, for total grade, the passing mark is 40%. Uh, so uh, you need to wait until your final exam in order to confirm whether you fail or pass this course APPD 1040. So I repeat again, for mid test and also for quiz, the passing mark is 50%. Is for test and quiz. For mid test, the weighted for mid test is only 40%. While the mark for your test is just will be carried forward only 40% for mid test, and then for quiz, the carry mark for quiz is only 20%. So the total is 60% from test and quiz, and then the passing mark for test and quiz is 50% of your test and also your quiz. This is the passing mark for for continuous assessment. Uh, for total grade, again, for total grade, the passing mark is 40%. Test plus quiz and plus final exam. Final exam will they are only 40% came up for final exam. That will be added to your test and quiz, and then make sure your total mark at the end of this course, after you take your final exam, the total mark is must make sure you get at least 40% in order to pass with grade D plus. With grade D plus. Okay. That is about the test and also our quiz. Okay. We are going to have another one quiz, and then the quiz will be held. There is no replacement for quiz. Just for your information, no replacement for quiz. I will have the quiz will be held during the class, and then I think subject to our class subject based on this current situation, we are going to have only two more class, and then so I think we will have at least one quiz, and then the quiz I will be held during our physical class face to face. In other words, there is no online quiz. Make sure you come to the face to face class, and then to take your quiz. Students who fail, for those who fail to take the quiz number 1, they will not be allowed to take another quiz. There is no replacement. Tidak ada quiz gantian unless for students who have MC. You need to come to my office. I will verify your IC. Later, I will decide whether you are qualified for the quiz or not. Otherwise, students who have not attended to the class during the quiz, you will not allowed to take the replacement quiz. That's why your attendance is very important. Okay, I think that's my answer. That's my response to the question about the passing mark and also about the quiz. Okay. As usual, if you have any question, you can ask me anytime. And for the lecture, okay, for today's lecture, I will explain about the what we call it differentiation. Again, what is a differentiation? Is one of the final exam topic. This topic number 6. Last 2 weeks we have a topic number 5, limit and continuity. So for final exam, our final exam we cover topic 5, 6, and 7. There are only three. There are only three topics. Okay. For today, I will discuss for differentiation topic. There are three file here: part A, part B, and part C. Okay, for today, I will discuss part A first, and then if we have enough time, I will proceed to we proceed to the part B. I hope you can pay your full attention. This topic is very tough for some people because this topic is involved the more calculation and more formula and more theory. Okay, what is a differentiation? By definition, the derivative or differentiation can be explained in terms of rate of change, kadar perubahan, or the slope of the tangent line. Okay, the slope of the tangent line is a one line. I will explain later. The slope is a gradient. The slope of the line. I explained about the slope of the linear function in topic 1. But okay, for this, when we're talking about differentiation, in general, differentiation can be defined as a rate of change again and the slope of the tangent line. If you refer to the this figure, please refer to the diagram on the second page. Okay, there. For example, let's say there are four lines here. We have PQ, line number 1, PQ1, PQ2, and one line we call it as a tangent line. Let's say we put it as a PQ3. Okay, there are 4 lines here: PQ, PQ1, PQ3, PQ2, and also PQ3. And then for this line, we call it PQ is a tangent line. Okay, how to interpret this graph? Okay, let's say we want to define our focus here is to define the tangent line at point P. Okay, we have one point here, point P. And then Q, let's say Q is one of the point on the graph. So we have we can draw one line here, PQ line, this line. We can draw this line. If you take a ruler, we can draw this line, that this line cross point P and point Q. P and Q. Okay, this line we call as a second line. Second, bukan not a line, second line. SECENT, second line ataupun line sekat. Because this line intersect a curve at 2 or more points. Okay, let's say we have one curve here. Okay, there is one curve. This curve is not linear. The red one, the red line, for example, there's a one curve. Okay, there's one curve here. Okay, we have one point on that curve, point P and point Q. Okay, we can draw one line, one linear line. That line cross the both point P and Q. Let's say we label the line as a PQ. Okay, by definition, this line is also known as a second line. What is the second line? Second line is referred to the line that intersect a curve at a 2 or more point, at least 2 points. So since the PQ cross the curve at point P and point Q, so we can call the line is a second line. Okay. Now let's assume that we want to move from P to Q. We want to move from P to Q. Okay. If you see, we can see here, if you Q move along the curve, and approach P from the right, we can draw another circle line, such as the PQ1, PQ2, and so on. We can have a more circle line here as long as we move from P to Q. And then in other words, we approach P from the left. So for example, I just draw two circle line, P1, PQ1, and PQ2. We can draw more than two circle line here. Just for example, I just draw two circle line, PQ1 and PQ2. And then when we approach P at point P, we can draw one line. Let's say line PQ3. Okay, this line only cross the curve at point P, only at one point. In other words, okay, in fact, we can say that PQ does not cross the line, does not cross the curve. PQ just touch or tangent the curve at point P. That's why the PQ is known as a tangent line, not circle line. Because for PQ, you can see here, PQ only touch or tangent with the curve at point P. So I hope now we know we have two type of line here: the circle line, PQ, PQ1, and PQ2, because this circle line has 2 points. This circle line cross the curve at the 2 points. Compared to the PQ3, the tangent line, the PQ3 only touch, or we call it in mathematics tangent, persentuhan, or tangent with the curve at point P. So in other words, we can say that the tangent line is a one line that tangent with the curve at a one point. So at this tangent line, this point P, this point is very important because the slope of a curve, a slope of the curve at point P equal to the slope of the tangent line PQ. That's why the tangent line is very important, because at this point, the slope of PQ equal to the slope of the curve. So by using this concept in this lecture, the slope of the tangent line, for example, for linear function y equal to mx plus c, we know m is a slope. I'm talking about the same slope here, but now in terms of tangent line. So in this lecture, in this topic, we will focus on the slope of we focus on this type of slope, this type of tangent line, and then we can say that the slope of the tangent line. How to find the slope? The slope of the tangent line will be obtained using this differentiation method. We're going to apply this differentiation method to find the slope of the tangent line. In other words, we can the first derivative what we call it, the slope of the tangent line is also we can obtain the slope of the tangent line by using the concept of derivative or the concept of the differentiation. Okay, there is a few types of derivative. How to find the derivative, I will show you later. we can use the first order of derivative. First order of derivative, and then the symbol of the derivative of the first order, perbezaan darjah pertama, perbezaan darjah kedua, can be written as, if you assume we have this function y equal to fx, the first order of derivative is written as dy dx, or equal to delta x delta y bagi delta x, or equal to y prime or f prime x. There is a few symbol for derivative. Dy dx is a derivative, delta y delta x is also derivative, y prime is also dy dx, f prime x is also derivative. And then we are going to apply this concept, this label, in order to find the derivative, especially the first order of the derivative. Okay, how to find the derivative? How to calculate the derivative? Basically, the derivative can be used. Basically, there are two methods to find the derivative. Basically, there are two methods to find the derivative. The first one is we call as a first principle method. Kaedah prinsip pertama. In bahasa Melayu, kaedah prinsip pertama. Or the first principle method. The second one is about the rule of differentiation. Rule of differentiation, we call it is kaedah pengambilan ataupun peraturan dalam kaedah pembezaan. Or in bahasa Melayu, we call it as also a petua pembezaan. Petua pembezaan. Okay, that's I'm going to explain this method, these two methods. The first one is about the kaedah prinsip pertama. The second one is about the petua pembezaan. Okay, now what is a kaedah prinsip pertama? I hope you please refer to page 3. I will explain. This concept. Whether there is a first principal method or rule of differentiation. Basically, we are going to explain this point. How to find this point? The tangent line. The tangent line to a curve at the particular point. For example, point P. So again, when we're talking about the tangent line, what is a tangent line? We can define that the tangent line to a curve at the particular point is a straight line. So the tangent line is a straight line. Garisan lurus. There must be a straight line. And then this straight line touch or tangent the curve at a point, for the example, a point P, and has the same slope as the curve at that point. So in other words, at the tangent line, what happened at the tangent line? At the tangent line, the slope of the tangent line is also equal to the slope of the curve. And then the tangent line is a straight line. It's also a linear line. There is the best line. The best line is used to find the slope of the curve. Okay, that is about. Now in this class, when we're talking about the differentiation, basically we're talking about the tangent line. What is a tangent line? Tangent line is a straight line, and also a tangent line is a line that has the same slope with a curve at that tangent point. Okay, now how to find the slope? In other words, how to find the tangent point, the slope at the tangent point? There are two methods. The first one is we're going to use the first principal method. The second one is a rule of differentiation. Okay. Okay. Uh, okay. What is the first principal method? Please refer to page 3. I will explain one by one. I hope you can pay your full attention here. How to find the first derivative, or the first dy df. Kaedah pembezaan pertama, the first degree of dy dx, the first or the first order of derivative by using the first principal method. Okay, I will refer to this example. We refer to this to the example. Please refer to page 3. Okay, let's say the first principal method. Call it as the first principal method. The first principal method. The first principal method. Let's say we have this equation. Y equal to 4x squared plus 7. We know that this linear with m equal 4 and c equals 7. You have learned about this in topic topic 1. We know this a linear function. This linear function has m equal to 4. The slope is 4, and then the c is 7. This m is also known as the dy dx, the first order of derivative. At the end, we get this result. So how to get this? How to define the dy dx? By using the first principal method. Okay, the first one, we assume that this function is y equal to fx, and the change in x, delta x equal to h. Okay, just we assume that the function is y equal to fx. The changes in x, perubahan dalam x equal to h. We assume that I assume the delta x is equal to h. I hope you can follow this explanation, because in the text not we do not use delta x. In order to simplify this process, I change delta x to x. We can assume delta x equal h. So the first step is we just to add this. We just add this function. The first step, we just add this function, or this one. We have fx x plus h. We assume that there is changes in x. The changes is x is delta x, and then now the value of x equal to x plus h. X plus h. Okay, that is the we just add h. What is h? H is changes in x, perubahan dalam x. So for the function, we just substitute x into the x plus h. For x squared is equal to 4x to the power of 2 for x squared plus 7. That's the first step. Okay, we can solve this equation. This is equal to 4x plus x squared equal to x plus x plus times x plus h plus 7. So this is equal to 4. X times x is x squared plus x times x h plus the second part is h plus x, another x h, and then the last one is h plus h. This is a h squared. Now we have this equation. 2, this is a 2. Yeah, we're again here. Another this x plus x h close the bracket plus 7. Okay, now we can simplify this. Okay, this is equal to 4x squared. Xh plus xh is equal to 2xh plus h squared plus 7. So this is equal to 4x squared plus 4 times 2, 8xh plus 4h squared plus 7. Okay, that is the first step. The changes in x, we just put the changes in x in the question. Okay, if you have any question, you can ask me anytime. Okay, the second step is to subtract, tolakkan. The second step is to subtract step 1 with the original function. Okay, the x plus h that we obtained from the first step minus the original equation. So in other words, the second step is to subtract, to minus, to tolak the first, subtract the step 1 with the original function. The original function is fx. Okay, from step 1, we know that fx plus h, this one, this equal to 4x squared plus x h plus 4x squared plus 7. This from step 1 minus the original function. What is the original function? Okay, this one. This is the original function, 4x squared plus 7. Okay, that is step number 2. Okay, so this, we can simplify this. This is equal to 4x squared plus x 8xh plus 4h squared plus 7. We just remove the bracket, minus 4x squared minus 7. So again, we can simplify this equation now. 4x squared minus 4x squared, we can eliminate. Okay, the answer is 0. And then we have 7 minus 7, also the answer is 0. So the equation obtained from step 2 is equal to x h minus 4, sorry, plus 4h, 4h squared. Okay, that is the question from step 2. Okay, the step number 3. We just divide step 2. What is step 2? Step 2 is the first, the equation for step 1 minus the original equation. Divide this step 2 with or divide step 2 by h. What is h again? H is delta x. Changes in x. So we know that from step 2, we get x h plus 4h squared divided by h. Okay, so we can simplify this. Okay, the answer is x 8x plus 4h. Okay. So the step number 3. Okay, the last step number 4, we find the limit. Find limit had for step number 4. By step number 4, the limit for the this function fx plus h minus fx divided by h when x, when h approach 0. When h approach 0. So this is equal to the limit of x 8x plus 4h when x, when h approach 0. So based on topic 5, when we explain about the limit, how to find this limit, we just replace based on the rule of the limit. We know we can find the limit by replace h equals 0 in the question. So this is equal to 8x plus 4 times 0. The answer is 8x. 8x. The limit when h approach 0 for the function is 8x. So in conclusion, we can say that if y equal to 4x squared plus 7 dy dx based on the rule of the differentiation, the dy dx equal to 8x. Okay, that is the answer. That is the answer. Okay, based on this, okay, sorry. So based on this equation, sorry, there is a not linear. This typing error. It's not linear. This is a quadratic. It's not linear. Okay, sorry, this is not correct because this is a linear. Sorry, this is a quadratic, not linear. Again, I repeat. In the example, y equals to 4x squared plus 7 is not linear. It's a linear function, but there is the equation. There is a quadratic equation. So the first derivative of the equation is dy dx equal to 8x. This is based on the first principle method. Based on the first principle method. Okay, that's all about the first principle method. You can refer to this page. But for this class, the first principle method is very important. You need to know that basically there are 4 steps in this method. And then you need to know how to find the derivative by using the first principle method. You need to memorize these 4 steps. Step 1, step 2, step 3, and the last one is to find the limit. In order to find the limit, you need to review back the topic 5, the limit and continuity. Okay. Okay, that's about the first principle method. Okay, any questions so far before I continue to the next section? Any questions? Please respond.
No,
No
doctor.
question, doctor.
Okay, thank you. Okay, the next one is about the rule of differentiation. Petua pembezaan. Okay, how to find the dy dx by using this rule? There are a few rules here. Rule number 1, rule number 2, 3, 4, 5, 6, 7. And then I think until the 8, 9, 10, 10, 11, 12, and the last one is the chain rule, the rule number uh, number 13. You can refer page 4, page 5, page 6, and page 7. Okay, I will explain one by one the rule of differentiation. Please refer to the page 1, page 4, 5, 6, and 7. There are four page here. Okay, what's rule? Okay, the rule number 1, the rule of differentiation number 1. Please refer to this page number 2. Yeah, number 1 is about the rule of differentiation. The number 1 we call it as a derivative of constant. Derivative of constant. P derivative 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 of constant. Derivative constant. Okay. Wait, I need to check my text first. Mm, okay. What is the derivative constant? Okay, derivative constant we refer to the constant function. For example, let's say I have this function y equal to -3, or y equal to pi, y equal to e to the power of 2. That's all. These are the constant function, because in this case the m is 0. So the derivative of the constant function, the answer is 0. dy dx, the dy dx, based on this rule. No need to find the fourth step. In this case, we are not applied the concept of the first principle method. The first principle method is the theoretical part of the derivative. There's four steps here, but based on the rule of differentiation, we can skip the process just to get the final answer. For constant function, what we call it, for constant function, in other words, for constant function, the dy dx is always equal 0. Dy dx is always equal 0. So there is the rule of for derivative of constant any constant function. The first derivative for any constant function is 0. As long as the function has no slope, the slope is 0, the first derivative is also equal 0. That is the rule number 1. Rule number 2. Rule number 2 is derivative of power of x. We call it as a derivative of power of x. Derivative of power of x. For example, what does that mean? Okay, if y equal to x to the power of n, for example, y equal to x to the power of n. Again, y equal to x to the power of n. the dy dx, the first derivative, dy dx, or we can also it as a y prime equal to n x to the power of n minus 1. Nx to the power of nx to the power of n minus 1. After we take the first derivative, the power will reduce by 1 unit. For example, let's say I have this function y equal to x to the power of 5. See, for example, I have this function y equal to x to the power of 5. The first derivative y prime equal to 5 x to the power of 5 minus 1 is 4. That is the answer. The derivative of the x to the power of 5. Again, we have this. I have this function y equal to x to the power of, let's say, negative 3, for example. The first derivative dy dx equal to negative 3x to the power of negative 3 minus 1. So this is equal to negative 3x to the power of negative 4. That is the derivative of power of x when the value of the power is negative 3. Okay. So, okay, that is the rule of the power. The next example, let's say I have this y equal to x to the power of 1 over 2, 0.5. The answer is 1 over 2, 0.5 x to the power of 1 over 2 minus 1. So this equal to 1 over 2x to the power of negative 1 over 2. Or this can also be written as 1 over 2x to the power of positive 1 over 2. The power of 1 over 2 is also equal to 1 over 2 times square root of x. That is the correct answer for this example. The derivative of the power of x. Okay. So the next one, if you refer to page 4, okay, the derivative of power of x, okay, we can also have this function. For example, let's say I have this function fx equal to 2x to the power of 2 plus 3 in bracket to the power of 5. Okay, I have this function 2x squared 2 plus 3 in bracket. All of them are to the power of 5. You have to find the first derivative dy dx or f prime x. Okay, we have one question 2x squared plus 3, but the question is also have another powers. The value of the power is also 5. So we have x to the power of 2, and the whole equation is also to the power of 5. So how to find the dy dx? Okay, the first step, we just follow to the rule of the power of x. Okay, so we have this power. This question has the power of 5. So this 5. We write the equation 2x squared plus 3. Now the power is become to 5 minus 1 is 4. 5 minus 1 is 4. So we have finished. We have just differentiate or dy dx, or find the, we just get the first order of the derivative where by using the power of x. But remember, in this bracket we have another question here. The question is 2x squared plus 3. So for this example, what we have done, we just find the derivative from the outside of the equation, outside of the bracket. But in the bracket, we have another equation, 2x squared plus c. We must differentiate this equation too. Okay, this one, in other words, the first derivative of 2x squared is 4x. And then the derivative of constant plus 0. So the answer is, we know the answer is 5. We can simplify this equation. 5 times 4 is 20x times 2x squared plus 3 to the power of 4. That's the answer, the right answer for this example. Okay, the next one is derivative. Okay, any question before I continue for this?
No questions, Doctor.
Okay, thank you. Derivative of log function. Okay, what is a log function? Based on topic 1, we have a y equal to log y. For topic 1, well, the log function is y equal to log bx. We have this function y equal to log bx. The first derivative, the dy dx for this function, y prime, this equal to the formula. If you refer to page 4, the formula based on this equal to 1 over x log b e. If y equal to log bx, the first derivative is equal to 1 over x dy dx equal to 1 over the x log b e. E is an exponent, the value of e. Okay. For example, let's say I have this function. For example, y equal to log to the power of log 2x with base 2. For example, y equal to log 2x. Y equal to log 2x. The first derivative, dy dx equal to y prime equal to 1 over x times log 2e. Okay, that is the answer. That is the answer. That's the rule of the derivative for the log function. You need to remember this step for log function. Okay. The next one, okay, another example. Let's say, if you refer to page 4, we have one question here in a log y equal to ln x. Y equal to ln x. I hope you still remember what is ln x. Ln x stands for log with base e. I hope you still remember log with base e. So based on this formula, the dy dx y prime, the dy dx equal to 1 over x log e of e. Log e of e. So if you refer topic 1, the rule of exponent, the concept of exponent, log e minus e must equal 1. So the answer is 1 over x. So we can conclude that if y equal to ln x, I think you can remember this concept. If y equal to ln x, the first derivative of y equal to ln x is 1 over x. I think that's very easy to find, to remember this part. Okay, the next one is about the, okay, another example here. Let's say I have this function y equal to log 2 3x squared. Okay, now we have one function, we have a log function here, but we have another function in the logs. We have 3x squared. Okay, there is another function. This is a quadratic. So in order to find the dy dx, y prime equal to dy dx, y prime equal to dy dx. Okay, based on the rule of the derivative for log, is equal to 1 over 3x squared log 2e. Okay, that is based on the based on the derivative of log. But remember, we have another function here, 3x squared, this one. So for this concept, we need to add the first derivative of 3x squared. So the answer is 6x. So we can simplify this equation. This equal to 3 times 1, 3 times 2. We can dismiss, or we can delete. We can replace the x. So this is equal to this 2 over x, 2 over x times log 2. Okay, that is the correct answer. Okay. Okay, another example here I can share with you is we have this natural log function y equal to ln x. So ln 3x squared. Y equal to ln 3x squared. Okay, this also equal to log e 3x squared. So based on these properties, we can write the first derivative dy dx equal to 1 over 3x squared log e of e, and then the derivative of the second of the of 3x squared is 6x. So then this part is equal to 1. Okay, this 3 times 1, 3 times 2. We can slash this this part of the power of x, and then the answer is, we can know that now this answer is 2 divided by 2 divided by x. That is the answer. Okay, that's the rule of log. Okay, the next one is about the derivative of exponential. Derivative of exponential function. Exponential, T-I-A-L. Exponential, T-I-A-L. Be careful, T-I-A-L. Exponential. Okay, what is exponential? Okay, the function for it is y equal to b to the power of x. Sometimes we also read as a to the power of x. That is the exponential. That is the exponential function. We have y equal to bx, or y equal to a to the power of x. That's we have the base, the exponential, and also the log as a base. For example, we can write the base of the function is a or b, or any other number. So how to find the derivative? The first derivative of y y equal to if a x ln e or b x ln b. Okay, that's the exponential of the derivative of exponential. Okay, for example, let's say I have this function y equal to phi to the power of x. The dy dx y prime or dy dx is equal to phi x. We just write again this function phi x ln phi or ln a. Okay, that's the derivative for the exponential. It's quite easy, yeah, but you need to remember the step. I hope you can appreciate the step for find the derivative of exponential and also the another derivative for another function. Okay, and then let's say the second example, let's say we have this function, this log function y equal to e to the power of x. I hope you can imagine the graph for this function. How the function look like, how to draw this graph. This very basic function of log e to the power of x. So based on this rule, this equal to y equal to ex ln e. So the answer ln e again is log e of e. The answer is 1. So the answer is e to the power of x. That's the derivative of the exponential function. Okay. The next one, let's say we have this example. Another exponential, y equal to phi to the power of x squared plus 3. We have another function in the power, at the power part, phi to the power of x squared plus 3. We have another question here. Another form of power in terms of that power x squared plus 3 is another equation. So how to find the derivative dy dx? Dy dx. Okay, based on this rule, we know that this is equal to we just write again the equation x to the power of 3 ln based on this rule, this is ln a ln base ln phi. Okay, there is the first part of the equation based on the derivative of exponential function. This the first part of the function, but remember we have another function here. We have another function. This function must be differentiate. We need to differentiate this function x squared plus 3. We know that the answer is the first derivative of x squared is 2x, and then the derivative of 3 constant is 0. So we have this answer. So we can arrange this function. This also can be written as 2x ln phi, and then the next one is phi to the power of x2 plus x2 plus 3. That's the derivative of exponential function. Okay. There is a few more about the derivative. I hope you need to know this. You have no option. You need to know the concept, the rule of the differentiation. Okay, in general, okay, let's say, okay, the next one, okay, page 6. Okay, we have another rule here. You need to know Okay, if you refer to rule number 8, rule number 8 is about to differentiating a constant time a function. Differentiating a constant time a function. A constant time a function. Okay. How to find this? How to differentiate a constant time a function? For example, we have this one, 5x to the power of 4. The first derivative, y equal to 4 times 5 x to the power of negative 4 minus 1 is 3. Positive 3. Okay, based on this example, okay, this equal to 24 times 5, 20x to the power of 3 of 3. So the coefficient of the variable x, 2x squared, and so on, we must take into account if we want to find the first derivative. Okay, another one. Okay, let's say we have another question. We have a long question here. For example, y this cubic function equal to x to the power of 3 minus 10 plus 1 over x to the power of 3. Let's say I have this example. We call it the sum and difference of the function. Sum of differences function. Okay, we have one rule here. The rule is called as a sum of different rule. Sum of differences rule. We add or we minus. For example, we have x squared, x cubed, x to the power of 3 minus 10 plus 1x to the power of 3. Okay, this question can be written as x3 minus 10 minus we have to the power of 3 plus x to the power of negative 3. There's a same question, the identical question for y. Y equal to x to the power of 3 minus 10 plus 1x to the power of 3 is equal to x to the power of 3 minus 10 plus x to the power of negative 3. Okay, the question must be in a linear, in a one line here, in order to find the differentiation. So the dy dx y prime is equal to, the first part is negative 3x to the power of 2 minus the constant one, then it's constant 0. Okay, x to the power of 3. Okay, the power of the equation of x is negative 3 based on the derivative of the power. If you refer page 4, derivative of power of x. Okay, this is equal to x to the power negative 2 plus 1 is negative 2. Negative 1, sorry, negative 3 plus 1, negative 3 minus 1. No, it's positive, negative 4, because negative 3 minus 1. Okay, negative 3 minus 1 is equal to negative 4. So the answer is, we know the answer is 3x squared plus 0 minus 3x to the power of 4, or this also known as a 3x to the power of 2 minus 3x to the power of positive 4. Okay, that's how we modify our answer in terms to get the better equation. We need to take into account all the conditions, whether the numerator, denominator, log power, the linear part of the function. Okay, that's the one of the examples. Okay, the next one, to refer to page 6. Refer to page 6. There one type of rule of differentiation. We call it as the product rule. The product rule. What is the product rule? The product rule is one method. We have two combinations. Let's say two functions gx and fx. Gx and fx. Okay, let's say for example we have y is equal to the combination of x times gx. We have two equations here. Two functions. We combine it together in one equation. We have fx dx, for example. So the first derivative of this example, dy dx equal to y prime. Okay, there is I will share with you the tip. Okay, the first one we just write fx times the first derivative of gx plus the first derivative of x times gx. Okay, that's the rule for the, we call it as the product rule. Okay, for example, let's say I have this function, y equal to x squared minus x times x plus 2. I have this type of question here. Okay, assume that, okay, we assume this is fx. The first one is fx, the second one is gx. Okay, in other words, I can write fx, I can split the equation into fx and gx. Fx equal to x squared minus x. The gx, we assume that is equal to x minus 2. In this case, we need to find the first derivative of y. The first derivative of y. And the first derivative of y, because we have two fx and gx. Based on this rule is the first one we just write again fx. It is x squared minus x, and then take the first derivative of gx. Gx is x minus 2. The derivative of x is 1. The derivative of x the first derivative of gx. What is it? X minus 2. Sorry, this is x minus. This is x minus 2. So we write the fx function, the function of fx, and then we must take the first derivative of gx. Gx is x minus 2. The first derivative of x dy dx equal 1, based on the rule of derivative. So this equal to 1 times the second part. We just differentiate fx. Okay, differentiate fx. Fx is 2x minus 0. X 2x fx 2x minus 1. And then we just copy again the question of C. Then be careful when you write your answer. Make sure you follow the procedure. Fx times first derivative of gx plus first derivative of x times gx. In order to get the to find the answer, we need to simplify the equation. So based on this rule, the product rule, the answer is we can write x squared minus x. We can remove the equation plus these are 2x times x, 2x squared minus 4x. Sorry, 2x squared minus this x squared minus x plus this one 2x minus x 2x minus 2x times x 2x times x, then the next one x times 2x times negative 2. There is a negative 4x. Then negative 1 times x, negative x, plus positive 2. So the first derivative this equal, we can simplify this equation. Okay, this equal to 3x squared minus 6x plus 2. Okay, it's quite long answer here. You need to write your answer step by step. Make sure you get, in order to get the right answer. Okay, the conclusion, because there are two equations here, we need to the first part is to differentiate the first equation. The second part is to differentiate the second equation. Okay, this the rule number. This the about the product rule. Okay. Any questions so far? I think we take a break because there's almost 12:30. Any question before we take a break?
No, doctor.
Okay, no question. Okay, if there is no question, we take a break for 20 minutes. We continue at 12:50. Is it okay?
Okay.
Okay, we take a break for 20 minutes. We continue at 12:50. Rehat dan sambung balik pukul 12.50.